Hello friends, in the last segment we have learned what is behavioral modeling in VHDL. In this segment we are going to talk about data flow modeling. So let us have a small recap. What is VHDL? VHDL stands for Very High Speed Integrated Circuit Hardware Description Language. Now this is a hardware description language. It means we use this language for describing hardwares, any digital circuit. Now basic structure of the VHDL code consists of library, entity and architecture. Library contains different types of data types, operators, packages and inbuilt functions. Entity describes inputs and output ports of the digital circuit, and architecture describes a relation between inputs and outputs described in entity. It basically shows how your circuit behaves. Then we have also talked about different types of VHDL modeling. So first is structural modeling. Structural modeling, as we know, that it describes how components in circuits are connected to each other, or we can say it gives you idea about structure of any digital circuit. Behavioral modeling, we use this type of modeling for synchronous types of circuit, and it shows how your circuit behaves. Data flow modeling we are going to study in this segment. And last is mixed type of modeling, which uses about 3 types of modeling or together, or any 2 types of modeling together to describe any digital circuit. Now for describing data flow modeling, we are going to use full adder as an example. So first of all, let us know what is data flow modeling is. Data flow, as the name suggests, it shows how your data flows in any digital circuits from input to output port. Basically, this type of modeling we use for concurrent circuits to design combinational circuits. Now let us design full adder. Now what is adder? Adder is a circuit which adds any 2 bits or any 2 numbers. Full adder is a circuit which has 3 inputs and 2 outputs. So here a block is shown, which is named as full adder. As I said earlier, it has 3 inputs A, B and C in, and it has 2 outputs, C out and S. S stands for sum and C out is for carry. Now what is there in this block? That we will be studying in the next slide. So in this slide, truth table for the full adder is shown. As we have seen earlier, full adder circuit has 3 inputs. So A, B, C in are our 3 inputs, and it has 2 outputs. So sum and carry are our 2 outputs. Now we have 3 inputs. So 2 raised to n is equal to n is number of inputs. So 2 raised to 3 gives you 8. So we for 3 inputs we have 8 combinations of the inputs. So for each combination we have calculated sum and carry. Now how to calculate this? We have to just add these 3 input bits. So in first combination A is 0, B is 0 and C is 0. So if we add these 3 bits, we get sum 0 and carry is also 0. In next combination, A is 0, B is 0. So if we add both the zeros, we get 0. Now this 0, if we add with this 1, we get sum as 1 and carry is 0. So like this, we have to calculate or we have to add these inputs and corresponding sum and carry values we have to calculate. After obtaining sum and carry values, for each output we need to draw a K-map. We are not going to study that in detail because we have already learnt it in our previous years. So if we draw a K-map for sum, we get this kind of equation, and if we draw a K-map for carry, we get this equation. Now from the equation, we can draw a circuit for full adder. So as we are seeing, sum is equal to A XOR B XOR C. So in this operation, we are seeing two XOR gates. Hence we have drawn two XOR gates, and XOR operation of A, B and C giving us sum as an output. So for carry, it is a combination of the ANDing and ORing operation. So here three AND gates are used. This is first, this is second, and this is third. So like that we have used three AND gates. This is first, this is second, and this is third. So first AND gate is for ANDing operation of A and B. Second AND gate is for ANDing operation of the B and C in. And third AND gate is for ANDing operation of the C in and A. And instead of using two OR gates, we have used one OR gate having three inputs. So outputs of the three AND gates, if we give as an input to OR gate, we get carry as an output. So now we have cleared with the basic knowledge of the full adder. Now let us write VHDL code for full adder using dataflow modeling. So next video is for VHDL code of full adder using dataflow modeling. Thank you.